Hello and welcome to our class ENGI307, Data Analysis and Machine Learning. My name is Dr. James Johansson, and I'm looking forward to going through this material with you. The contents of this course, we have it broken up into 8 modules, and so there'll be 8 lectures which will break into parts. And so for this first lecture, we're going to be doing an introduction to what is machine learning. So after we get into that, what we're going to do is to focus more specifically on different types of machine learning. And so each of these chapters all the way up until this last one will be focused on different techniques. First of all, we'll talk about supervised learning, is where you have a training sequence that you're taking into a machine and actually getting a chance to learn from that. And so then when you have future data that is not based on a training set, you're going to be able to do well with that information. The next category is statistical learning, where we're using statistics to come up with models using things like Bayes' theorem or a naive Bayes way of selecting if it's one thing or another. And so we're starting to do some classifications using those types of techniques. Next, we'll be talking about support vector machine, where we can start to be taking all the different characteristics that we have from our samples and starting to make some interesting ways to come up with a way of categorizing them, clustering them using the techniques using vectors. For an example would be looking at handwriting analysis. Next, we'll get into neural networks. And if you think of the way the brain operates with neurons, we'll come up with an artificial neuron and having multiple layers of a system that helps us to be doing machine learning with that way. Another technique is having trees. And so we'll be creating decision trees where each one of those branches that you get more and more specific, that you're going to basically branch down to a level that's going to cover the details. And that is another way that you can be analyzing data. Another area is data clustering, and you can be thinking, say, like a 2-dimensional graph, and you'll have different areas where they collect. And so we'll be looking at possible ways of how you can be making the data so it would actually do that kind of clustering. And so this would be more of a survey of a couple of techniques that are used for that area. And finally, we'll be giving a general thoughts with this last lecture on exploratory data analysis, bringing things together, and this general category of data transformation, including the principal component analysis. And by the end of the course, that will be a little bit more clear to you what that actually means. So for this first lecture, we're going to talk about these types of things. And so we want to give a scope for what we're going to be covering in this class. This is a survey course. We'll be talking in general about the different types of algorithms and theory that's involved with machine learning. And then we'll get into the basic premises and guiding principles that are used in machine learning. So we'll be talking about how we go about doing architecting a learning machine. And so we'll give a definition for what machine learning is. We'll talk about the different types of learning. And by me going through the table of contents, we at least had an initial idea of how that would work. We'll talk about the relationship between artificial learning in AI, data mining, and deep learning. And so artificial intelligence is the highest level. And then the next level gets into data mining. And below that, getting deeper, more looking at big data, we get into deep learning. So that's just a quick synopsis of what we'll be looking forward to as we get into the details for this particular module. So like I said, this is an introductory class on machine learning. What we're going to do is share the basic premises and guidelines for machine learning. And so there's two possible ways that you could be considering how you're going to be teaching and you learning this material. And what we're choosing to be doing here is to focus on the theory. That is in compared to what can be considered a black box. It's where you have a technique, you use it, and then you try and see how that would work. Our thought is we'd like to have you be doing that as a follow-up to motivate students to take follow-up courses or self-study learning projects and what have you. We'll be doing a little bit with MATLAB to at least give you an exposure of what that would look like. So how would we define machine learning? And so a computer program is said to learn from experience with respect to some class of task and performance measures if the performance of the task as measured by the performance measure improves with experience. And so the operative word is improving with experience. And so what are the features of a well-defined problem? First is the learning task, which is dealing with what is to be done. And so what are you trying to do with your learning machine? The second is coming up with the measures of performance. What are the expectations on how it's supposed to do when it gets new data? And finally, the task experience, which deals with categorizing what the problem is, and thus the type of problem is going to help dictate what types of the machine learning strategies that we're talking about in this course. So the basic premises of machine learning are as follows. The real world is pervasively imprecise and uncertain, and precision and certainty carries a cost. And so how much are we willing to pay for to get that precision and certainty? The guiding principles of machine learning are as follows. We want to exploit tolerance for imprecision, uncertainty, and partial truth to achieve tractability, robustness, and low solution cost. And so that's a introduction to what is machine learning. Okay, I'll take a break there and we'll continue in just a minute.